This is my inquiry. We investigated the question, will the amount of light affect how fast the boat will travel? Giving a quick overview, we kind of used a previous inquiry activity where we built boats and tested the speed of them against each other, like kind of more like a race. We used that, and I explained the features of the sensor tag and how it operates. So my students came up with their question on their own based on all of this stuff. They came up with the question on will the amount of light affect how fast the boats would travel. They wanted to do something on the amount of wind, but we couldn't with the sensors that were included in the tag. Students used the boats to time how long it took to get from one side of the tub to the other. They tested each one 3 times and then averaged them. They tested it with the 3 different amount of lights. We did both lights on in the classroom. We did 1 light on and then no lights on. This was the handout that I created. The students were able to fill that out as they were testing their boats. They used the timer, the tub of water, their boats for each trial. After 3 trials, we changed the amount of light in the classroom. Each time we changed the amount of light, we measured it with the sensor tag. So we came up with both lights on being 150, 1 light on 101, and no lights on was 68. The 68 is due to probably the natural light that was still coming in through the window. Here are some pictures of the boats. These are a few of the group's results. As you can see that their average is still around the same on each of them. Doesn't matter if they're up in the 4s, 1 second, how fast they were. There within their own group, it was about the same. The students noticed that there is no clear distinction between the amount of light and the speed of the boat. The students observed that each group's speed were very similar within their own results. For example, if the boat went 3.4 seconds with no light, it went 3.3 and 3.6 with 1 light and both lights on, respectively. We discussed as a class that these speeds are so close that there is not a correlation between the amount of light and speed. This aligns with STEM practices, as Bradford and Donovan stated in Scientific Inquiry and How People Learn, but science is about questioning the obvious. I was a little unsure about allowing my students to conduct this investigation. I thought, is it too obvious and is it too easy? And then I remembered that STEM is about investigation, exploration, and cognitive processes. My students need to be able to take ownership of their inquiry. On the journey to come up with the question, does the amount of light affect the speed of the boat, one student offered the idea that they have never seen a boat go at night. His prior knowledge and experience of only seeing boats sail during the day led him to believe that yes, the amount of light does affect the boat's speed. In the article, How Students Learn, Bradford and Donovan explained that new understandings are constructed on the foundation of existing understanding. My activity most resembles Figure 8.7 of What is your perspective on STEM education, as it combines science, math, and technology, but unfortunately does not incorporate engineering. It adheres to the tenets of inquiry. This activity adheres to the tenets of inquiry by allowing the students to investigate the information for themselves. I could have easily explained to the students that making the room darker would have no effect on the speed of their boats, but allowing them this opportunity to investigate themselves gives them ownership and cognitive skills past the pure facts. I struggled to decide what level of inquiry this activity was. The students chose the question to investigate, but they were given parameters as it had to relate to one of the sensors. As the class, they agreed upon the procedures of the method to test the question, and they shared the results in pairs. My students required a lot of support and guidance. I don't think it is a true open inquiry, especially since the article, The Many Levels of Inquiry, explains that students starting at the 4th grade level can begin to experience these, but neither the question nor the procedure are completely given to the students. According to the matrix for assessing and planning scientific inquiry, I could make it more complex by moving the students choose from a pool of questions to the students generate the question and investigation based on their own experiences. This activity is on the learner, self-directed end of the inquiry continuum, as the students are in charge and create most aspects. To improve it next time, I think I'm going to use a steadier method to blow the boats across. I want to use a larger tub and an easier way to fill it up. I want to use more tools to measure more aspects, such as the wind speed and the temperature, and I want to allow the students to graph their results. Thank you so much.